we want to take integral of dx over square root of 16 minus x. If you look at the previous formula, which you had just a second ago, that's the one which you will be using. Then you realize immediately that a squared equals to 16, so a equals to 4. So if you do that connection, then you realize that a squared equals to 16, so a equals to 4. And then we are ready to write on the right side of our formula, and we're going to get our answer. Oops, it should be sine inverse, right? Sine inverse here. So we're going to get sine inverse of x over 4. Let's see. In a similar fashion, can you do dx of square root of 81 minus x squared? Integral dx square root of 20 minus x squared. Can you write down the answers for these two? So for first one, a squared equals to 81, so a equals to 9. And then we just retrigger the formula, so we're going to get the answer, sine inverse of x over 9 plus c. Second one is a bit more confusion. Not much, but still. So we're going to get a squared equals to 20. So a equals to square root of 20. And square root of 20 is 2 root of 5. Because 20 is 4 times 5. Square root of 4 is 2. And square root of 5 is square root of 5. As soon as you figure out what a is, we are ready to write down the final answer. So we're going to get sine inverse of x over 2 root 5. So that's how a shortcut is going to work in this case. Let's try one more. Integral dx square root of 9 minus 16x squared. Here we'll start with substitution. Okay, so let me try to illustrate what kind of substitution we're going to be doing. So we want to use that formula. So we want to use integral dx over square root of a squared minus x squared. That's a formula which we want to use, right? So from here, we know immediately a is going to be 3. But that coefficient in front of x, that's what throwing us off. Because to use a formula, we need to have only x squared and we have 16x squared. So what we're going to do is we're going to call that 16x squared our new variable. So what we're actually doing is we're going to call it square of new variable. Then u is going to be 4x. Then du will be 4 dx, and dx will be du over 4. And the reason we want to do that substitution equals 4x because we wish to have that 16x squared to be just variable squared. Something like this. So if you like, you also can treat this one as integral du over a squared minus u squared. That's maybe even more to a point than 16x squared is supposed to be u squared. Then we proceed with that substitution. Square root of 9 minus u squared du over 4. I'll slide it somewhere on the side, so I don't want to deal with complex fractions. So instead of saying and writing du over 4 on top somewhere here, I'll just slide it next to, then I don't have to deal with complex fractions. It's kind of easier to me to see that right way. And then we see that 1/4 is coefficient in front, du over square root of 9 minus u squared. And we should be able to finish at this. So finish it up. And in a second, I'll put the final solution on the board as well. So let me try. 1/4 is 1/4, stays in front. We don't want to forget it. And A is going to be free, so we're going to get sine inverse over 3. And u over 3, and we recall that u equals to 4x. So at least that's what I. One more example when we'll have to do substitutions. Integral dt sine inverse t square root of 1 minus t squared. So the good thing right now is that we don't have many tools to work with integral. So basically have only one tool, which is substitution. So that's the only tool which we have, so we're going to be using it. If we had more tools, that will be more confusing which tool to choose. But right now we have only hammer at hand, so we're going to be using hammer. Okay, so what's going to be u? If you look at the expression, essentially we have only two choices. It's either sine inverse of t or square root of 1 minus t squared. Sine inverse t, I agree, that's a better choice. But if you're not sure, another opportunity might have been square root of 1 minus t squared. That's another opportunity, right? So if you don't succeed with sine inverse, then that's what we want to do. So let's try this sine inverse. So you're going to find du. Recall what's antiderivative. I mean, that's what derivative of sine inverse. That's what we're learning right now. And if you have good eye, you don't even have to do anything else after that. Much. I mean, what is going on here is, if you look at the integral and look what we've got so far, then you immediately realize that is du. You don't have to solve for dt. So what you're going to get is integral. That expression becomes du. Sine inverse is u, and you get that integral. Then this to negative exponent, u to a negative 1 du. We'll use power rule, so we're going to get e to the 0 over 0 plus c. Okay, what's wrong? Right, how I got 0? Our rule says you have to start with your initial one, right? At 1, and you have to divide by. So what you're going to get is, so every time you run to a problem and you end up with dividing by 0, perfect. Then what is going to be happening here, you immediately realize something is wrong. You cannot divide by 0, so cross it off. And then you recall that actually is 1, which you better memorize. That should sound familiar. It's 1 over u, 1 over x. U to the negative first is just natural. That's a special case. Do back substitution.